I'm pleased and honored to be able to speak with you today concerning one of my favorite topics, and that is advanced production scheduling. And in particular, we want to talk about advanced production scheduling in the context of managing a prototype shop. And we want to talk about automotive prototyping challenges in particular, although what we're going to discuss also applies outside of the automotive field. We're going to talk about the power of APS to address those challenges. We're going to talk about what it means to deploy APS in your organization, and then we're going to have a bit of open discussion, Q&A, concerning some of the subjects that we've covered. All right, well, let's begin with advanced prototyping challenges. Managing a prototype shop, what does that mean? Well, it means multiple objectives. A prototype shop manager or director has to accept multiple prototype programs, each with their own start dates and end dates. That person's going to be responsible not just for documenting disparate production material flows, but communicating those to the supervisors and the operators who have to build various prototype programs and have to go through and do that in a series of steps, which are typically happening concurrently. There's not just a single prototype working its way through the shop at any given time. There's multiple prototypes, and that raises the possibility of collision, contention, and confusion. In order to head off those issues, a prototype shop manager wants to reserve time frames for specialized days, for test platforms, for skilled operators, so people know what to do, when to do it, so that individuals and equipment aren't torn between two projects or two places at the very, very same time. Similarly, you've got to optimize the utilization of specialized days, test platforms, and skilled operators. One possibility to avoid collision and contention is often to space things out, whether it's in time, whether it's in shifts or calendar days, but that might lead to a suboptimal utilization of those specialized days, test platforms, and skilled operators, and sooner or later someone's going to notice. Sooner or later, management, either of the prototype shop or level above, is going to say, we really do have either a number of operators and or a number of days, expensive equipment that's not working to capacity. What's going on? Maybe the prototype shop doesn't need all of those people or all of those things. So you really want to be able to optimize the utilization of the resources at your disposal. You want to track the progress as prototypes move through the system to explain internally within the prototype shop and externally to business units and sometimes suppliers and customers specifically what's going on. Transparency is good, opacity is bad. And with a good advanced production scheduling system, you can not only make confident statements about the future, you can make confident statements about the past and present. You can identify issues and delays before they become crises. Again, we know that to expect the unexpected, and an advanced advanced production scheduling system can help you understand whether an issue that has arisen is something that can be easily accommodated or something that calls for a reshuffle of the schedule, that calls for reallocation of resources, that potentially calls for overtime or even a request for an extension. People don't like to do that because people who are managing prototype shops, ultimately they want to achieve the quality and quantity and calendar targets for prototype completion. That is the North Star for the prototype shop manager. And an advanced production scheduling system can really assist you in that endeavor. And we're going to talk specifically about Preactor, which is a Siemens product, Systematic IT Preactor Advanced Production Scheduling. Let's step back for a minute. We're talking about advanced production scheduling. Let's define the term. Any advanced production scheduling system is going to store defined sets of shop resources and product routing. Those are relatively static but not entirely static. What's more dynamic are the orders and shop floor status, which are imported from outside systems typically. The orders being imported from upstream representing organizational demand, and the shop floor status essentially coming from downstream of the production scheduling logic to say, okay, here's what has completed, here's what's in progress, here's what's not started. The advanced production scheduling system is then going to help the production controller build a schedule based on this most current information. That's an important word, help. A good APS is a decision support tool. It doesn't replace the production controller. It doesn't replace the manager. It supplements the knowledge and the calculation power available to him or her. And then finally, when a schedule has been created, an APS system is going to give the production controller a way to publish the finished schedule. Preactor provides all of those essential capabilities. On a main workspace screen, we have a central switching station for a number of functionalities. Here in data maintenance is where we can find the defined sets of shop resources, the defined product routing. Those have often been imported from upstream, but they don't have to be. And in any event, they can always be reviewed here and if necessarily manually updated. We can, from the workspace, we can import orders, we can import shop floor status, and then based on that information generate a schedule which is subsequently released or published to the shop floor. And to help visualize the schedule, what does it mean to generate a schedule? Well, here we have a classic Gantt chart where specific orders are routed across various resources. At this point in time, those would be listed over here on the left. I'm not going to get into many specifics. There's a lot of ways to follow an order through the system. For instance, orders might be color-coded. You see, for instance, this light blue cascading through the system as it moves from one operation to the next. There are a lot of ways that the Preactor interface allows the production controller to evaluate the schedule before publishing it and also to change it. There's a lot of drag and drop capability. The controller can change the order of operations that are performed on a specific resource. If there's a certain resource that is capable of, if there are multiple resources that are capable of performing a certain operation, the production controller can shift those operations from resource to resource as needed. It's a decision support tool. Sometimes that schedule that Preactor creates on the first cut is the right schedule, is the best schedule to move forward with in that day or that week. But if it is, the the production controller has a lot of latitude. And then ultimately, the finished schedule can be published in many forms. Here I am just showing a particular report that comes out of the Preactor system, which lists specific products and part numbers and their specific start times. This is the sort of report that can be handed to the operator of drill A and say, okay, this is what we expect you to do, and these are the time frames in which we expect you to complete it. There are a number of other reports, and also there are a lot of data feeds. Most often, this information is also fed into other electronic systems, which might distribute the instructions to terminals, might distribute the instructions to an internal website. There are many options, but these are the essentials of an advanced production scheduling system, and specifically of Preactor. And what I'd like to do now is to talk about the power of APS to address some of the challenges that are inherent in managing a prototyping shop. One great thing that an advanced planning and scheduling system can do is to help production controllers gain visibility to potential contention and to resolve it in advance. Preactor can anticipate contention or overutilization of specific resources and then either flag it for the production controller or automatically adjust the schedule to prevent it. What I'm going to show you involves this first option, but Preactor can be configured to do either. Let me bring up my laser pointer again. Here we see the Gantt chart again, and now we're again seeing that these specific resources are listed, the specific pieces of equipment, as well as the operators, the drillers and platers. And where plating is concerned, what we can see, if we look at these gray bars, we see that we have platers, as many as we need, when we need them. There's a total of 4 on staff whenever the shop is open. And we can see that the gray, the number of platers at work, is always within the red line, the number of platers available. Now, if we look at drillers, we see a different story. We're actually okay by the time we get out into the future. Here we can see we've got a varying number of drillers. We've got 2 on the first shift and 1 on the second. But the issue that arises, particularly at the start of the schedule, is that the number of drillers required exceeds the number of drillers available. You can see the gray rectangle popping up above the red line. So that immediately tells the production controller that, oh, as pretty as this schedule might look, it's not feasible. So there are a variety of options. At this point, the scheduler may be able to talk to management and say, we want to bring in some operators from another shop or another unit. The production controller said, we can resolve this if we extend the schedule and work some overtime over the weekend. Right now, there isn't anything happening on the weekend. Once the issue is seen, once it's detected, it can be resolved before it becomes a crisis. And there's generally a number of degrees of freedom. Now, I should say that, again, what we see here represents a configuration in which these types of contention, what we call secondary resources, in this case the employees, the contention, the overutilization is simply flagged. There are alternate configurations of Preactor in which this wouldn't be tolerated at all, and consequently, the Gantt chart here would be stretched and spaced out so that no more than the available number of drillers would be designated for work at any given time. That is really, really helpful. It's very visual. It's the sort of thing that can also, because it's so visual, that makes it an aid for decision making and for communication. This is something that even someone who's not a specialist can see and understand and appreciate and perhaps and hopefully be persuaded to take action. So much of management is communication, and there is the need to manage upstream and downstream, to manage needs and to manage expectations. When it comes to managing needs for parts and materials from upstream suppliers, well, those suppliers may be internal or external to your company, and they have certain inputs that have to be available at certain times. With a prototype shop, it's difficult to run a just-in-time system. But on the other hand, you don't necessarily want to wait to start a prototype until all parts and all materials are available. So you want to, the prototype department wants to know, to be able to know, when to request or demand the receipt of input from these upstream suppliers, who are internal or external, to say, I anticipate a certain step to begin next Wednesday. You must have those parts, you must have those materials available to me next Wednesday. Also, with the visibility that APS provides, prototype shop management can manage the expectations of downstream customers. Now, the customers for a prototype shop are typically internal. Those are going to be your engineering and or your manufacturing departments. The Gantt charts and reports that a mature APS system output, they not only track progress for the benefit of the prototype shop management, but they help prototype managers communicate status to other business units. These, again, are very effective and visual tools for communication to be able to say, yes, this particular part is on track. And I know it because I see it here. We can follow it through the Gantt chart. We have, whether it's a week or a month of leeway in order to address the unexpected. These things can be shown, communicated, so that the expectations and emotions of downstream customers can be directly addressed. And of course, there is the need, the genuine need, to respond to changing circumstances. Prototyping is susceptible to the causes of variability that are encountered in any other industrial or manufacturing process, right? You can have machine downtime. You can have supplier delays. As much as you want everything to come from upstream as possible, the reality is sometimes it doesn't arrive, and those delays from your suppliers can result in delays on the shop floor. Rush orders. Sometimes things come more quickly rather than slowly. Sometimes a certain prototype becomes more important than the others and has to jump to the front of the line. These are all the sorts of variability that can occur, whether you're in a prototype shop or a make-to-stock shop or a make-to-order shop. But then prototyping is also susceptible to domain-specific causes of variability. There may be ambiguous or incomplete instructions from engineering that have to be addressed, and while that dialogue takes place, work on the prototype can be suspended. Another example could be material failure. When making a prototype, you're often pushing the material or pushing a skilled operator to craft the material in a way that it has not before, and often the result is a higher scrap rate, and the result is potential delay. Sometimes the geometry, by the way, sometimes it's not that you're applying new or unfamiliar geometry to a material, but a new type of metal that is being worked. And this metal has properties that our shop is not accustomed to dealing with. We're a learning organization, but until we do, there's scrap, there's delay, and these things can happen and happen more often in a prototype shop than in a make-to-order shop or a make-to-stock shop. So again, you're going to want an APF system that can rapidly recalculate a schedule based upon the knowledge that certain operations are taking longer than expected, that one of the bars on that Gantt chart is stretching out farther in time than was originally hoped. Okay, what impact does that have on the orders and operations around it? When the production planner can assess that, then the planner can recalculate and rebuild a feasible production schedule. Sometimes Preactor can find ways to shuffle those blocks in a way without making any other changes. Sometimes the answer is, whoops, we're going to need to work overtime in order to address the delays. But again, the graphical power of Preactor helps make the business case, helps explain, yes, this is not just overtime we're working for our general comfort level. This is essential because, as we can see on a Gantt chart, without it, there is going to be a serious delay. There's going to be a serious delay in a specific order and the orders around it. I wanted to talk a little bit about the steps involved in deploying an APS system, and those begin with analysis and design. Typically what PMC does is an extended period of discovery of the business processes, of the prototyping processes, of the IT systems surrounding those. Based on that, we can perform a functional analysis and a technical analysis and bring those together in a system design. Now, we move on to the build phase, the building both of the APS system and the IT system and feeds around it. And I wrote here that technical teams implement this. Why is that S in parentheses? Well, because this is a stage at which we work with our customers to find out how much of the effort and responsibility they want to carry, particularly on the IT side. Sometimes the customers that we deal with will say that they want PMC to really design the entire pre-processing and post-processing apparatus that surrounds the Preactor software. Other times they say, no, that's not necessary. That's what we have an IT department for. Just define the interfaces and we will create the data feeds. So there are a lot of options. There's no one way to do that. And really, ultimately, we're going to have multiple teams involved. And the main question is to be answered up front and then to be followed through with is, how is that responsibility divided? As we implement, the customers and subject matter experts and production controllers test it. They tell us what's wrong and what's right. That is one cycle of the iterative process of building the overall system. And then based upon that feedback, changes are made and more tests are conducted. One thing about this iterative process is in the first few cycles, there is a lot of effort here and a little effort here. But as we move forward, we anticipate more and more effort from the customer as they test to a more and more detailed level, and then reach the point where they say, yes, this does satisfy our requirements. This system does help us prototype according to our constraints, to our rules, to our capabilities. And then at that point, we can launch. We can install the Preactor client. We can install the server components such as databases, license servers, and application servers, activate the data feeds, and then cut over from the old scheduling system to the new. This is a process that involves PMC working very, very closely with our customers, and it is, I can tell you, very satisfying for all when the system goes live and the promise of Preactor and the promise of APS is realized.